We are at the final stage of industrialization for the units that will be used in the demo case. And it means that we are finalizing all the documentation and the internal procedure required to start the units in mass production. So the happening technology consists of a technical way to introduce the renewable energy in residential building by minimizing the impact of the refurbishment in the building itself. It means that the key point that we try to develop is a solution where we can actually change the central generator, that is actually a boiler usually, and change the terminals, that is a radiator in the most common application, with units that are able to work with energy renewable. Usually this means that we are removing the boiler and putting an air-to-water heat pump, and we are reusing the piping system that was present in the building, circulating water at a low temperature for heating. And we have developed a small micro heat pump that is actually is doing the function of the radiators and is working subtracting energy from the water loop and putting this energy inside the space to heat the rooms. Of course, this system is also another important point that allow the user to have also the cooling function that is usually not possible with just the radiators. And another important part of the technology is the domestic of water generation. So we have developed a specific unit that can work on the water loop, like the space heating unit, in order to heat up a tank for the requirement with the domestic hot water.
Then the main advantage of this, and at the same time a big challenge, is how to design smart controls for this, because having this set up in comparison to a traditional radiator means that you have a lot of options of you having smart controls that minimize your energy consumption and have the whole system run in a standard way. If you have only a boiler and a heat pump, then this is fairly straightforward. You just have a heating curve. The colder it gets outside, the warmer you make your water in the boiler, that the radiators radiate more energy. If you have heat pumps, you can do significantly more things. So you have storage systems that you can use. You can run it at different temperatures. You have all of those options. And in order to do this smartly, you need to also understand what is going to happen in the future, not just what is happening now. So what you will do is you will have a forecast as to what you think is going to happen in the building for the next 5 hours, 10 hours, 24 hours, 48 hours. And then you build those forecasts based on like past occupancy, past data that you have based on weather forecasts. And then on the other side, you use those forecasts to optimize the system. So for example, if you know that you have a very cold night ahead, where you would prefer not to use the main heat pump, then it helps to load up the storage. If you know you have a very sunny day up ahead, then it makes sense to have your battery as empty as possible to absorb as much as possible of the solar energy into your storage system. If you know that you have more solar energy than your battery can cope, then it makes sense to have your tank empty, that you can use this energy when it becomes available to heat up the tank, then use it later on in the way.
The process of implementing the technology after that the units are developed and defined is actually the dimensioning of the requirement in energy of the building. I mean, so you need to keep in consideration the actual demand for capacity of the building, capacity both for space heating or domestic of water. And then you need to dimension the central heat pump in order to be able to provide the capacity required by the whole building. And then you need to do the definition and the dimensioning of in any room, I would say, of the suitable unit for that and for that room, in capacity and in volume available.
The second part of fitting the happening system into buildings once you've installed, like designed and installed your hardware, is to design and also install the software. So all the forecasting systems I was talking about, obviously every building that you have has a slightly different occupancy. So you might have a building where you have a couple of people living that work in a bakery that happen to get up at 2 a.m. So they like to take a shower at 2 a.m. In another building, you might not have this. So you will try to have your optimization algorithm to actually learn from past usage patterns. So if we see that for the last month, 5 days a week, somebody's been taking a shower at 2 a.m., then I better make sure that I have an efficient way of providing hot water at 2 a.m. And also with the weather forecast, you need to obviously have a weather forecast for this location, which we have like the standardized forecast, but what we also do is we record the weather at the site. So if we realize that usually the weather forecast is 2 degrees too low, then we know, okay, we have the global weather forecast, and we turn this into a localized weather forecast. We know, okay, if this weather forecast says it's going to be 5 degrees, then in reality it's probably going to be 7 degrees. So we have all of those local adaptations that run automatically. So we make sure that the software that actually controls this and that runs the smart control is up to date and knows what is happening on the inside. So all of those machine learning and AI techniques that we use for forecasting, they get tuned to this particular building, that they learn the habits of this particular building.
INNOVA is contributing with happening project with the technology required to develop the unit for this specific application. Because inside the unit there is I would say, the state of the art of residential heating and cooling system. I mean, this unit will be propane based as refrigerant. Will have the inverter system mounted inside, and the most important thing that we are implementing all the solutions that we have developed in the last project in the course of the experience that we have in INNOVA, in order to minimize the noise of the unit, because the important point to keep in consideration is that we are placing a heat pump directly in the room where people lives. So this point is actually the most important, together with the high efficiency that is required for this application, that are the requirement of efficiency is met through important work of dimensioning of the heat exchanger, and because we have choose for this project the best heat exchanger available on the market, and this is actually our contribution to this project.
The contribution of EURAC to this project comes in the form of the smart control and the optimization component. So this whole setup, as we explained before, has a lot of options for optimization, a lot of LAs for smart control, for ensuring the most efficient optimization, but they need to be found, and in a lot of ways they're not trivial to be found, because you need to look into the future. And this is exactly the part that EURAC is contributing to this project. So Matteo from INNOVA is contributing the units, and we are contributing the knowledge and the ways to finding the most efficient way to run those units. And in the end, in order to achieve the goals we've set for happening, we'll need both. We need the best hardware that is possible to be built, and we need the smartest way possible to build it. And this will be the contribution of EURAC.